lesson, we will be learning how to simplify rational functions and expressions, and we will be applying these techniques to solve problems. So when we're simplifying rational expressions or functions, we want to recap some key terms. One of them would be rational function. What is a rational function? Well, it is any function that is the ratio of two polynomials. A rational function can be expressed as, notice the notation of function, f at x is equal to p at x over q at x, where p at x and q at x are polynomials and q at x does not equal to 0. And that's really important. Our denominator can never equal to 0. That would make the function undefined. So an example would be f at x, that notation, is equal to 2x minus 5 over x plus 2. We're also going to be looking at a rational expression. And a rational expression is a quotient of polynomials. So looking at p at x over q at x, where both p at x and q at x are polynomials and q at x is not equal to 0. See the difference between a function and an expression? The function has that function notation f at x, whereas an expression does not. So an example of a rational expression would be 8 over x plus 3, or another polynomial p at x, which is a squared plus 3b squared, over q at x, which is a squared minus b squared. P at x and q at x, as mentioned, are polynomials, and q at x can never equal to 0. And that leads to something called restrictions. Restrictions are the values of the variables in a rational function or expression that cause the function or expression to be undefined. These are the zeros of the denominator. So in order to determine that, we set the denominator equal to 0 and solve for the variable. If the denominator contains 2 or more terms, the zeros can be determined from its roots before the function is simplified. Equivalently, they are the numbers that are not in the domain of the function. So when we look at these restrictions, those values of our variable that result in the denominator equal to 0, those are points where our function is undefined. So let's look at an example. We have state the restrictions of the given rational functions or expressions. So in A, we have an expression, 2x minus 1 over 3x. Now, again, restrictions are where our variable results in our denominator equaling to 0. So to state those restrictions, we're going to take the denominator, set it equal to 0, because we know it can't equal to 0, and then we're going to solve for x. So in this case, to get rid of that 3, we're going to divide by 3. What you do to one side, you do to the other. So in this case, the restriction is that x can't equal to 0. And you can quickly check. If you sub in x to be 0, your denominator would result in 0, because 3 times 0 is 0. So therefore, we can state x can be any number, but it cannot equal to 0. That is the point where our function is undefined. Looking at B, we're now given a rational function. F at x is equal to x squared minus 2x plus 3 all over 4x minus 1. Again, restrictions, we set the denominator to equal to 0, and we solve for x. So bringing over that minus 1 is 1, divide both sides by 4. X cannot equal to 1 over 4. So therefore, x cannot equal to. So we do have to apply all our factoring skills. And if you look at C, we have y is equal to 2 over x squared minus 25. So what you want to identify is that's a difference of squares. So our factoring skills have to be strong. Okay, so we say y is equal to 2 over x minus 5, x plus 5. Okay, so when we state our restrictions, we have 2 of them. We have x minus 5 cannot equal to 0, or x plus 5 cannot equal to 0. So simplifying, x cannot equal to positive 5, and x cannot equal to negative 5. So therefore, x cannot equal to positive or negative 5. If x's, positive or negative 5, that would result in our denominator equaling to 0, and that would make that function undefined at that point. So when it comes to restrictions, you're expected to restrict any variable that would make the denominator equal to 0. The restrictions on the denominator and the domain of the function end up becoming the vertical asymptotes of the function. Key concepts to remember. For all rational functions, the domain is the set of all real numbers except those numbers that make the denominator equal to 0. And that's why we have to figure out and to determine those restrictions. So steps to simplify rational expressions: factor the numerator and the denominator fully. State the restrictions by finding the values that make the denominator equal to 0. Note, restrictions must be made before you divide out anything. And divide the common factors between the numerator and the denominator. So let's look at example 1. We want to simplify and state any restrictions on the variable. So we have 36x to the power 4 plus 18x cubed plus 9x squared, all divided by 9x. So looking here, we see that the denominator is 9x. So our restrictions would be let 9x equal to 0, divide both sides by 9, x is equal to 0. So we know if x was 0 in this case, our denominator would be undefined. And that's why we say x cannot equal to 0. Okay, so now let's try to factor. So looking at the numerator, we look for a common factor amongst all those terms in that polynomial. So it looks like 9x squared would be a common factor. So we divide all of midterms by 9x squared, and we're left with 4x squared plus 2x plus 1 all over 9x. Okay, simplifying, we're left with those 9's cancel out. The x squared divided by x is simply x. We're left with x, 4x squared plus 2x plus 1. And we would state where x, comma, x cannot equal to 0. Looking at B, again, we always want to make sure that when we state our restrictions, our denominator can never equal to 0. In this case, we try to see if we can factor out the denominator, and they do have a common factor of y squared. Actually, 2y squared, even greater. So you look at 2y squared. If we take 2y cubed divided by 2y squared, we're left with y minus 4. When your denominator is fully factored, it's a little bit easier to state and see the restrictions. So in this case, our restrictions include, we know 2y squared cannot equal to 0, but we also know y minus 4 cannot equal to 0. Both of those factors, we need to determine what value of y would result in the denominator equaling 0. So we set that equal to 0 and we solve. So we're left with y squared is equal to 0. Y, again, cannot equal to 0. So that's one restriction. And then we have y minus 4 can't equal to 0, bringing that over. Y cannot equal to 4. Which means with this expression, y cannot equal to 0 or 4. Looking at C, we have x plus 1 over x squared minus 1. So again, that's a difference of squares. So we do have to really remember our difference of squares. We can say x plus 1 all over x plus 1, x minus 1. So just recalling, when we are factoring a difference of squares, keep in mind that's a special case. Identifying the first terms of perfect square, because x times x is x squared. 1 times 1 is 1 squared is 1, and you're taking a difference. So you set up the two brackets, x is the first term in each bracket, and the root of 1 is in each bracket. Now, if you notice here now, we have a scenario where there is a common factor of a binomial. So we can say, simplifying here, we can take x plus 1 divided by x plus 1, so we're left with 1 over x minus 1. Now, again, x plus 1 at one point before we simplified was part of the denominator, that value of x has to be considered for a restriction. So for our restrictions, we would state, okay, set x plus 1, even though we simplified, at one point it was in the denominator, it is considered to be a restriction. So we solve for x is equal to -1, x is equal to +1. So in these cases, x would result in the denominator equaling 0. So we can say x cannot equal to plus or minus 1. Okay, moving on to D, we have 4a squared b plus 8ab all over 6a squared minus 6a. So again, let's try to figure out what is a common factor amongst our two terms in our numerator. 4 is a common factor. They both have an a and they both have a b. So we can say 4ab. And if we factor that out, we're left with a plus 2 all over a common factor between 6a squared minus 6a, we can say is 6a, and we're left with a minus 1. Now, if you notice, we can reduce 4 over 6, and we can cancel out this a. So we're left with 2b, a plus 2, all over 3a minus 1. Reminding ourselves that 2 goes into 4 twice and 3 times. If you can reduce fractions, always do so. So if you notice, we did cross out that a that was common, but since it was in the denominator, it is part of our restriction. So any variable that exists in the denominator is a restriction. So in this case, I can say a cannot equal to 0, and we have a minus 1 cannot equal to 0. So simplifying here, a cannot equal to 1. So we can say a cannot equal to, oops, sorry, at the simplified form I should be putting this, a cannot equal to 0 or 1. Okay, so again, in the simplified form, which we did up here, which is good. Look. Y cannot equal to 0 and 4. X cannot equal to positive or negative 1. Okay, looking at E, we have x squared plus 5x minus 6 all over x squared plus 3x minus 4. Now again, those are simple trinomials, so we want to factor both. Because looking at the denominator, it's hard for us to tell what values of x would result in that being 0. So that's why it's important to fully factor. Keeping in mind you're going through all your steps and making sure if there is a value of x in the denominator that would result in it being 0, it has to be part of the restriction. So looking at the numerator here, we have the middle term is our sum. So we can say something plus something has to equal to 5. Something times something has to equal to -6. So thinking of two numbers multiplied together to give you -6, those same two numbers added together to give you 5. So that would be 6 and -1, 6 and -1. So to fully factor the numerator, we'd have x is the first term, and again, +1 minus 1. It doesn't matter on the order, but those are the two numbers that satisfy both the sum and the product. Likewise, in the denominator, our sum is equal to 3. Our product is equal to -4. So in this case, we'd say 4 and -1. 4 plus -1 is 3. 4 times -1 is -4. So to factor that, we'd have x plus 4 and x minus 1. Okay, with that in mind, common factor of x minus 1, and we would simplify x plus 6 all over x plus 4. And of course, we need to state the restrictions. So restrictions include any factor that results, and we did simplify, so x minus 1 cannot equal to 0, and x plus 4 cannot equal to 0. So in this case, x cannot equal to 1, x cannot equal to negative 4. So to state those restrictions, x cannot equal to, and again, always in increasing values, so negative 4 and positive 1. Looking at f, we have m squared minus 4, which again is a difference of squares, and then we have 5m plus 10. So in the numerator, difference of squares, we'd set up our two brackets. M is the first term, minus 2, positive 2. All over, factoring out a common factor of 5m, we're left with, oops, sorry, not 5m, just 5, I apologize. 5, and then we're left with m plus 2. I notice we do have a common binomial, so we can simplify that, and we're left with m minus 2 all over 5. But keep in mind, even though we simplified with that common factor, that binomial is still part of the restrictions. So we would let m plus 2 equal 0, and that's it. Okay, so therefore m, if I brought over that 2, m cannot equal to negative 2. There we go. M cannot equal to negative 2. Okay, so reminder restrictions, the values of a variable that would result in the denominator equaling 0. Looking at example 2, we have write a simplified expression for the function defined by the following. So we have k at x is equal to negative x squared plus 9x minus 18 all over 15x minus 5x squared. So what I suggest you do first is always arrange all our terms in decreasing values of x. So if we look in the denominator, we have negative 5x squared plus 15x. Okay. The numerator has a simple trinomial, but not kind of, it's kind of hidden because we have that negative out front. So we're going to factor out that negative 1 so that we're left with a negative 1 out front, and then we have our simple trinomial in our brackets. In the denominator, we're going to factor out a common factor, negative 5x, and we're left with x minus 3. Okay, so now that we have that simple trinomial, we're going to say two numbers added together to give you negative 9. Same two numbers multiplied together would give me positive 18. So thinking of two numbers multiplied together to give you 18, those same two numbers added together to give you negative 9. So that would be if the product is a positive and the sum is a negative, both numbers must be negative. So if we take that, negative 6 times negative 3 is positive 18. Negative 6 plus negative 3 is negative 9. So we're going to factor out this negative 1 is out front. We have x minus 6, x minus 3 all over negative 5x, x minus 3. So again, we have a common binomial that we can simplify. Okay, these two negatives leave me with a positive, and we're left with x minus 6 all over 5x. Okay, remember, when stating our restrictions, even though we have that common binomial of x minus 3, that is still a restriction because at one point it was part of the denominator. So x minus 3 cannot equal to 0, so x cannot equal to 3. Likewise, we have 5x cannot equal to 0. Divide both sides by 5. X cannot equal to 0. So therefore, our expression in this case, x can be any value, but x cannot equal to 0 or 3. Looking at h at x, we have the polynomial x squared minus 7xy plus 10y squared all over x squared plus xy minus 6y squared. So again, these are simple trinomials, but we just have two variables involved. So looking at the numerator, again, two numbers added together to give you -7. Those same two numbers multiplied together to give you 10. So again, when the product is positive and the sum is negative, we know the two numbers have to be negative. So -5 times -2 is +10. -5 plus -2 is -7. So we're going to set up our double bubble. X is the first term in each bracket, Y is the second term, and then we include the two numbers we came up with that satisfied the sum and the product. So again, that was -5 and -2. Okay, looking at the denominator as well. Again, it is a simple trinomial, so I'm going to just bring it up here. We know two numbers added together to give you 1. Those same two numbers multiplied together to give you -6. So in this case, 3 times -2 is -6. 3 plus -2 is +1. So we'd set up two brackets. The variables are again are x and y, and the two numbers that we came up with that satisfied both the sum and the product are 3, +3, and -2. So when fully factoring, we notice we do have a common binomial that we can simplify. Okay, so we would say x minus 5y all over x plus 3y. Okay, but we do need to set our restrictions, keeping in mind wherever, so restrictions include, we set x minus 2y is equal to 0. And then we have x plus 3y equal to 0. So we want to know for what values of x would result in this denominator equaling 0. Well, x is equal to 2y would result in the denominator equal to 0, or x is equal to -3y. And so therefore, simplified, x can be anything, but x cannot equal to -3y or +2y. Otherwise, the denominator would equal to 0. Okay, moving on, we have find the ratio of the area of the square to the area of the trapezoid. Simplify if possible and state the restrictions on the variable. So when we're looking at that, we want to keep in mind or remind ourselves the different formulas. What is the area of a square in order to compare the two? So area of a square equals side squared. So in this case, it's already told us this is our square. So if that's 10x, then we know that this is also 10x. And that is 10x. That side is 10. All four sides are 10x. So the area of the square would simply be 10x all to the power of 2. Well, 10x times 10x would be 100x squared. So the area of the square is equal to 100x squared. We're going to take the ratio of the square, area of the square to the area of the trapezoid. So we need to determine what is the area of the trapezoid. Okay, the formula for the area of the trapezoid is always a plus b times h all over 2. Knowing that a would be this upper length, b would equal to this whole length. So it would be 8 plus 10x plus 8. So b is going to equal to 16 plus 10x, or I can say 10x plus 16. Okay, a we know is 10x. And then the height, which is again the height of the square, which is also 10x. So we're going to use that to determine the area of the trapezoid. So area of the trapezoid is equal to a plus b. So let's do that. A, which we know is 10x, plus b, which is 10x plus 16, all multiplied by h, which is 10x, all over 2. Okay, always following BEDMAS. So 10x plus 10x, which is 20x plus 16. And of course, because we can simplify, we can say 2 goes into 2 once, 2 goes into 10 5 times. So we're left with 5x. Or fully factored, we'll say 5x over 20x plus 16. So that would be the area of the trapezoid. And actually, it's not fully factored. What we should have recognized is, we do want to fully factor. Okay, so we have 20x plus 16. So if I was to expand that, we're going to say 20x times 5x, which is 100x. 16x squared, sorry, and then 16 times 5x, which would be 80, positive 80x. Okay, so if we're taking the ratio of the area of the square to the area of the trapezoid, simplify if possible, state restrictions on the variable. So we can show that ratio as a fraction. So we're going to take area of the square over the area of the trapezoid. Okay, so the area of the square we know is 100x squared all over 100x squared plus 80x. Now again, all the other examples that we have applied, we need to make sure we fully factor both the numerator and the denominator. So the numerator is a single term, so monomial, so that's fine. But we can factor out a 20x out of the denominator, and we're left with 5x plus 4. Okay, and fully simplifying, we can take 100 divided by 20, which is 5. X squared divided by x is simply 5x. So it's 5x over 5x plus 4. Now, of course, we do have, if you notice, 2 points where we have restrictions. Anytime there's a variable in the denominator, we know we have a restriction. So in our case, before we factored, we had 20x cannot equal to 0, as well as 5x plus 4 cannot equal to 0. So dividing that by 20, x cannot equal to 0. In this case, 5x is equal to negative 4. Divide both by 5. X cannot equal to negative 4 over 5. So stating our restrictions, okay, so when we find the ratio of the area of the square to the trapezoid, simply be 5x over 5x plus 4, where x cannot equal to negative 4 over 5 or 0.